sure that you change the working directory to the folder where you will save your program. So therefore, you could know where your programs are saved, and then you could file programs later. So this is my working directories in my computer. Right now, I'll show you. We need to build a new Simulink model. So you can see, just click here, new. Right, you can find Simulink model here. Just click, and then just wait. Then you see a new window pops up, and in which you could develop your model. So my computer is a little bit slow. Okay, now this is the window. You can save the program, build a program, and so I will save my program first. Make sure you save program first. And here I will type the name model CSTR. Right, save it. Make sure to save it. Alright, save your program every 5 minutes in case your computer crash, and then you don't have to do the work again. Right, and the second step here is you need to find the modules from the library. Right, so here, this one is the library browser. Just click it, and then you should see this is the library browser. Now you have the windows open, and you already have the module ready. So now you are ready to develop your own model. Right, so here, the first step here is, we have two differential equations, and then we have one equation to calculate k-value. So therefore, the first step for you is to set up the framework of the Simulink model. So therefore, we're going to set up the integrators for T and CA, and then we develop a function for the constant k. So therefore, we need to get two integrated blocks, and then one function block. And after that, we're going to set up the initial values for the T and CA. And so the T is here, and the initial values are given here. At the same time, I'm going to show you how to add the annotation and equations for each block, and so that make your program readable. So you're going to, in the future, and you develop a model, you're going to share your model with your colleagues, right? And so adding the annotation will help other people to understand your program and better, right? So here, this is the framework I'm going to show you. So we're going to have two integrators and one function module. But before I show you how to do the job, there are some tips for you to make your work easier. And so you could copy an existing block by just pressing the Control Ctrl, and at the same time click the module you would like to copy. Just drag the target block and module, and then you could make a copy. So now I want to show you. First I add, so this is going to add the integrator here, right? This integrator, and then let's see. After that, so just click here the label here. You should change the label. Here I change to CA, right? CA. Now you want to copy this integrator for the temperature, right? So you push the Ctrl bottom, and then you click the integrated module, and then you could drag the module and then make a copy. But you need to change the name here. This is for temperature, so T, right? Okay. And so let's come back to the handout, and you could double click the module or the block, and to open the another dialog box of the module, you could change the property of the module or block. And for example, you could specify the values of parameters, or you could specify the initial values of the variable here. So we double click here. So I'm going to show you how to add the initial value for the CA. So double click, right, and then this initial condition, right? You see here initial condition, and you know that the initial condition for the concentration of component A is 0.5. So you type 0.5 here, then OK. You double click, and here the temperature block, and then you change the temperature initial value is 350. Right, and then save it. Make sure that right after that, and we also need to add the module for the function. Right. So before I continue, I just want to show you. Then you name a variable in MATLAB, and you should not include any special characters other than the underscore. So for example here, this name is not correct, and because we have space between C and A, there's space. We should not include space in the name of the variable. Instead, you could use C and underscore A, right? This is the correct name. Now I want to show you how to add the function module. So you go to the library here, and then you could see user define function, right? Then you drag this one here, and then this for K. So you're going to type K here, just click, right? Remove the original label and change K. Okay, step 1, and this framework is done. Now let's go back to the handout. So now we need to specify the equations to calculate the array constant K. So we decompose the equation for A into 3 parts, right? So when you develop model in Simulink, you need to know how to decompose a long equation into different parts, and then you need to further decompose each part to smaller blocks and modules, and then you're going to bring this module together to build the Simulink model for the long equation. So here you will see we have this one block, this another block, and this block, right? So we have 3. So here we have 3 inputs here. So therefore we're going to develop a vector. I know you should learn vector from other courses, right? So this vector, this U1, U2, and U3. Okay. So we're going to develop vector here, just like here. So we're going to develop vector, right? U1, U2, and U3, and then use the vector as the input of this function. Okay. Right. So now I want to show you. First, I want to show you how to type equation in the function, right? So here you just double click and just type equation here. As I mentioned here, so we could change the equation to K U1 times exponential minus U2 and over U3, right? This is the equation. So we use U1, U2, and U3 here, right? So you could change here U1 U2, and U3. So we type here is this is equal to U1 times exponential, right? And then you time minus U2 time over U3. That's it. So this equation for the rate constant. Double and click OK. Right, and then you could stretch this block, and then you could see the equation. So I also recommend you to type the equation here, and to make sure that the equation you input in the module, right, is correct. So this is a good way for you to check your program, right? So this OR, activation energy, EOR, and OT, right? So you could see this K1 is equal to U1, and EOR equal to U2, and T equals U3, right? Okay, now we need to add the vector and for the input. So therefore we need to double click the vector concatenate, and to check, and here I'll show you it's in the category here is signal routing. So go to the signal routing, go to signal routing here, signal routing, and then you could get the let me see. Yeah, the vector concatenate, right? Drag here, and typically the default numbers of the vector in the elements, and here's 2, so you double click, change to 3 because we have 3 input, right? And then you could structure a little bit, and then you could link them. Again, you should type the physical meaning of each input here. U1 is K0, and U2 is E over R, and U3 is T, right? Okay, now what you need to do, you just need to input K and E over R, and then T, right? So we go to, and then K is a constant, so we go to the constant. Here the sources here, right? Constant, and for K0, so you just put here K0, and then you type the value of K0, the double click, you could get, so it should be 7.2 times 10 to the power of 10. So that's it. And again, you could stretch this one a little bit to see the value of the K0. So similarly, you could make a copy of the constant, but change this to this should be E over R, right? And then you put the value here, 8,750. Okay, and then you could this make it look a little better. So this is U1, so link the first one. This U2 link the second one, and U3 is the temperature. So here's the output of the T value, right? Okay. So save it again before you lose it. Very good. So we already done with the function to calculate K. So therefore, after that, and we could use the K, the output from the K function block, and to represent the K value. Now let me show you how to input the different equation and for the CA. So we need to decompose the different terms into different levels. For example, here, so the first we could decompose the different equation into 2 terms in the blue color, right? This is just term 1, and this term 2, right? So this is the level 1. This level 1 is high level, And then for each term, we further decompose the terms into different components. So for example, we could decompose term 1 into and the product of two terms here, right? Okay, so this is level 2, the red color one. And for the term 2, only have, you could decompose it as the product of K and CA, right? And for the term 1, and here after we in level 2, right? We could still further decompose these two terms here, right? And to smaller modules. For example, for the first one, you could decompose as Q divided by V. So, right, and the second one you could decompose the term as the operation of the minus of CAI and to CA, right? So so I use different colors and here to represent different levels. Okay, see this. So firstly, we decompose the equation into these two terms, right? And therefore each term we further decompose. For example, this and this, the product of these two terms, right? And then we further decompose this one as the CAI minus and CA, and this one is Q over A. Similarly here, and this K, and this is CA, right? Okay, so you could see that we should decompose the equations into smaller modules and until we get a level for the constants, right? For the constants or for the sources. For example, step input and pulse input and all kind of this input, right? So this input, right? So this the how you're going to develop the decompose the ODE and then to represent it in the Simulink. Okay, now let's work together to input the differential equation for CA. So here I don't use different color. I show you the colors in the handout, and just because it's easier for you to understand. But now to make the job to get a job done faster, so I don't show you in the using different color right here. Okay, so I could move this around and make it look a little bit better and neat, and we could save some space for other terms here. So first I will going to add so we could decompose the differential equation of the CA into the into one term minus another term. So therefore we need to add the minus subtract and operation here. So here we could get here subtract, right? And then we type the equation here, and after you type the equation, and you could check the equation easier, right? So you could type Q over V times C A I minus C A, right? The first term, and then the second term is minus K times C A, right? Okay, now we work on the first term first. So the first one is the Q, is the product, right? Q over V times and this term CAI minus CA. So therefore we add the product, we add a multiplication module here. So this is let's see, find the product here, right? So we're going to get put equation here. The first one is Q over V times C. You copy here, it's easier right? Just select it and copy, delete it, and then copy. Right, and the second one here is K times CA, so it's also a product module. So copy one, and then you put here K times CA, right? Okay, and then you could link here the first and turn minus the second turn. Okay, now let's work on this term first. So here we could get also here is so we have QV, right? And another one is CAI minus CA. So that we should work on this first. This is a minor. We can have a minor operation, and for this term, right? So we add a minus. So we could copy this one, right? But we change the equation here. It's the minus. Actually, it's CAI minus CA. And the second term is a divide, operation. So we could add a, let's see, I get the divide operation, divide of sphere. The second one is divide operation. Right, move it up. This one is Q over V, right? So we see the first one is so you can see this Q over V times, and here is the CAI minus CA, right? So we are done with this one. Okay, now we for CAI minus CA, so we need to add C and CA here, right? So you could switch now we have the positive on the top and minus on the bottom, right? You could switch them, and you don't have to do that, but I just want to make the model look better. So here's I changed the minus on the top and the positive on the bottom. So therefore you could get CAI minus CA. So this is this one is CA, alright. So you could move this around, right, and then just put the CAI here. So CAI is constant. So we add a constant here, source, alright, CAI here. So get CAI here, put CAI here, CAI, and you know that CI equal to 1, right? Good. Save it. Okay. So this is done, and now let's work on this one. That's Q over V, right? So we add a constant for Q, constant for V, right? So Q, this is V, Q, this is V, this is V, this is Q, and this is V. Right? Q is what? Q is 100, and double click V is 100 also. We already included the unit here. So Q and divided by V, so that's it. Okay, so therefore this one, the first one, Q over V times CAI minus CA is done. Now we work on the second one, K times CA. So and the output from this function is K, right? So this is K, and CA is the output of the integrator, right? So you draw this one, you can see this solid circle here. It means that you connect, you have to make sure that, and you have a solid black circle here to make sure that, and this line here, the input of here is linked to the CA, right? And then, okay, almost done, and then just link this one, the CA, so DCA equal to this term, right? So we are done with the differential equation for CA. Now let's continue and to work on the temperature, and we are done. So again, we could decompose the differential equation for temperature into different levels. Here we decompose in 4 levels, and we have for the level 1, we have turn 1 and turn 2 and turn 3. See, you can see here, right? This equation, right? We have 3 turns are added together. So this is the turn 1 and turn 2 and turn 3. Okay. So for each one we could decompose, right? So for example, this one we could decompose here and this turn divided by this turn, right? And then we could further decompose, right? This one is the product of 3 turns, so minus delta H R, and then this is the case, and this will be CA, okay? And this one again, here is the product of the mu, the rho, and C. C is the heat capacity. And similarly, we could for this turn, we could decompose them into the product of 2 turns, and then further decompose each turn, right? And then this is the last turn again. This should be U. Let's see. UA is not UV, so I need to correct my explanation in this diagram. Here should be UV. It's not UA. It's not UV. It's UA. UA is correct. This should be UA. This should be UA. Okay. Right. This should be UA. I need to correct the terms in my model. But anyway, it's easier for us to correct the labels in the Simulink, right? Okay, so and we could decompose it into the product of 2 turns, and then for each turn we could further decompose, right? Okay, now let's work together. So we need to add 3 turns here, right? We're going to work from level 1 to level 4, and for each level and for each turn. So and then we work on and turn by turn, right? So here we have the summation of we have the summation of 3 turns here. So we add this one first, okay? So here add it's not correct, and just click a long icon. So here we add the summation operations, this math, and here you should get the add operation here. But if you have 3 turns, so you double click, and then you could add another, just input another plus here, and then you get 3 turns, right? And then so I suggest you to put the equation here as minus delta H R and times K times CA, and divided by rho times C, right? Here C should be capital C for the derivative, for the capacity. I should put capital C here. But this is the first turn, and then the second turn you add. So you add here. So you add here. Well, you could define, it doesn't matter which turn is first turn, which turn is second turn, but you need to make sure that you include all the 3 turns. So here's M over rho times V, right? And then times Ti minus T by the second turn, and then the last turn here is UA, and divided by the rho times C times V, and then times TC minus T. Okay, 3 turns, and then link it. Right, this is the differential equation for the temperature. Move it around and have it to get enough space for all these 3 turns. Okay, now we need to add the first term first. Is the so you can see the minus delta H times and K times CA divided by rho. So we could decompose as 2 terms. The first term is the numerator. The second term is the denominator. Right? This is a divide operation. So here add divide operation. Then you copy these terms here. Right? Okay. And then link to the first one. Right. Okay. And then the numerator terms here is the product of these 3 terms, right? And it's minus. Copy these 3 terms in the numerator. So this product of 3 elements. So we add a product element here. So copy this one. Right, and then but you change it. The equation here is to be the product of these 3 elements, and you see the product of 3 elements. So we need to change this one. The number of input as 3, right, and then move it around. Okay. So therefore we have so we have K times CA. So we need to add K here. K is from this one. Let's see, I think the first one should be CA, is easier. So CA, this from CA, right? CA, and the second one is K, and the last one is minus delta HR. It doesn't matter which one go first, but you have to have the 3 elements times together. So we need to add this one. Delta minus delta H is a constant, so we need to add a constant term here. So this is a constant term. So this source constant, right? Just drag it, select it, and then drag it. This constant, right? And then change the name as the minus delta HR, and then here should be 5 times 10 to the power 4 powder and power 4, right? Good. So you could stretch this one a little bit to see the value of the minus delta HR, right? So then you could connect. Let me see. You can move this around, and then you can see the equation. So this is the first one, the numerator. Now let's work on the denominator. The denominator is the product of 2 elements. So we need to add a product element here. Copy this one, but change the name to the low to the C. So this change the name. Change here. Change equation. Right, link it. Right now you need to have a constant for the low, a constant for the C. So you could copy the constant here, and then this one change to the low, and the low is 1000, and then copy it, and then change this one to the heat capacitor C, and C equal to 0.239, right? Link them together into the first one, the second one, right? Move this around. Okay, so we are done with this turn, first turn. Now let's continue to work on the second turn here. The second turn you could decompose as the second term here is the product is the product of the first term, and then the second term is ti minus t. Alright, so we get product element here, but you change the equation, and here change the equation to low is w over low times v in times ti minus t. So the first term is the first term is w over low times v. Alright, so this is a dy and element here. So we module. So we added the dy module here. So the dy module is w. Right. So this is the second term, right? And then we get the first term here, w over load and also over v, right? And then we need to w. So we need to add the w here, the constant, right? And the second term here is in the numerator. In the denominator is the product of low times v. So we're going to add a product term here. Right, this one is low times v. Okay. So this one is the v w, right? So we add w here. W is constant. Add w here. Okay. W equal to, so I change the name here, is w equal to the low times q, right? So we know low is 1000 times q is 100. And so we put this here. Just this one a little bit. See the value. W is done, and now we need to get the low times v. So we need to add we already have low, so we need to add a v here. The v, actually we also have v here. Okay, so we have a low here. So we add a low first, low times v. So v go all the way back here. Okay, so save it. Right, we're done for the second term. Or not yet. We still have ti minus t, right? So we have such a module here. Here should be ti minus t. Change the name to that. Ti minus t, right? Correct. Connect it. So the ti. So we need to add ti as a ti is constant, right? Ti is constant. So this ti. So every time I add a module, change the name or input the equation, so that you could check your model easier, in an easier way. Like this ti. Okay, and t is from the integrator. Okay, now we're done with the second term, and then now we work on the last term. The last term is this one, right? So we can decompose as the product of two terms. The first term is ua over low and times c times v. The second term is t c minus t. So this is a product, right? This product of two elements. So we copy this product module, and then we change the name. And here we should change, right? And this is the third turn. So you can see we don't have solid circle point here. So therefore the signal from this module is independent from the signal on in this line. Okay. So we could further decompose. The first term here is the UA divided by a product, right? So we had a divide module here. So, but we need to change the name here is change the name here is this one, right? Kinetic, right? And then we need to add UA is constant, right? UA, just change to UA. UA is 5 times 10 to the power 4. Let's adjust this one a little bit to see the value. The second one is the product of 3 turns, right? 3 modules. We need to add a product module here, and then the product of 3 elements. Copy it, and you need to change the input here 3, right? 3. Okay. Then we already have the low. It's the low, and then we have the C. This is C. Let me see. We might use the first one as C. Right? It's easier to connect them. But anyway, you can move this around, and you don't have to follow my way. But you need to make sure that the 3 products, the product of 3 elements, right, and including C, low, and V. This is the V. Good. Then this is the denominator. Then save it. Control S. Then you can save it. Now we are done with the first turn here. The second term here is TC minus T, right? Let me show you. So I copy this one, and this is you need to add a subtract element here. Let me see. I copy this one, change the name. TC, and you could switch the location of minus and plus. I put plus first, then minus second, because this is easier for me to link to this minus T, so you could link the minus side to the T easier. And then here is TC minus T, right? And then TC is we have a step change in TC, right? We change the cooling water temperature from 300 and to 290, right? The first scenario. So this is a step change. So we need to go to the source here, and then you identify the step change, right? You put TC here, TC, and then you need to specify the change, right? So the step time is 0, so we change, and the value is time 0. Initial value is 300, final value is 290, right? That's it. Save it, and then link this one. Okay, I just show you how to change and add the step change in the TC, and so as you know, you could use the get a step block from the sources and category, and then we could double click the, as I showed you before, right? You could double click the step module, and then change the step time, initial value, and final value. So now we need to record the data, to plot the data, right? So so therefore we need to add record the time. So therefore we need to add the time module here. So here go to the sources here, and then you get a clock, right? Clock, and then now we need to record the clock, and here's the time t, right? So we need to record the time, temperature, and then the concentration. So we need to add here the sync block. So we add for the t time, Ca, and temperature t. We will save the data into the workspace block here. Show you. So here you will get a sync, and then you get the workspace, right? And then you will change the name of the variable here. So you double click, and then you change it to Ca, and the Ca profile will record it in this variable. And at the same time, very important here, you need to change the save format and to array. Yeah, this is very important, right? Because we're going to plot the Ca profile with the time, so this has to change to array, right? So this will get Ca. Similarly, we could make a copy for here for the time. The variable name is t, right? And then we get a workspace for the temperature. So the capital T. So in MATLAB and the capital and also the upper lower letters are different, right? So this temperature, time, and Ca, right? So if you want to show displays the final value for each element and for each variable, you could use the display here, display, right? This is the final value. So you could display final value for each variable, right? Just like a scope, but it's for the final value. Right, copy it, and then also if you want to know more about the information and you want to see time profile in the scope, you could do that. But I prefer you to plot the profile and instead of just see it in the scope. So link scope. Here you get another one. Copy scope. Okay. Save it. So again, I want to mention here again, you have to save the workspace. You have to save format as the array. That's very important, especially when we plot the data. So this is what we should get, right? Now we want to run the simulation. So before that, we need to specify the time for the simulation and also the ODE server. So to do that, so you go to the simulation here, simulation, and then you go into the model configuration parameters, right? And then the time here, we do the simulation for 10 minutes, so this 10, right? So time simulation time 10 minutes, and at the same time we change the ODE server to ODE 15S. S means stiff. S means stiff. So here S means stiff. Okay, what stiff means? Stiff, maybe you already know this. Stiff means and some variables change much faster than the others. So it's very tricky. And here to select the step size to discretize the model, and in the ODE server, right? I think you learned this in from Dr. Smith's course, and how to do the numerical get a numerical solution for the ODE, right? So if you don't know whether the model is steep or not, just pick ODE 15S, and because it works for both steep and non-steep problem, right? And after that, after you finish this one, so you already so you select the server, specify the time, and click OK. And also you could see specify the simulation time here, 10 minutes. And then just click run, right? And then very fast, it's ready. Only about 2 seconds, 3 seconds, it's done. Now we know that after simulation, the data is in the CA data, condition A saved in CA, the time, and then the temperature saved in the T, right? So here we need to do 2 simulations, right? One simulation is for to reduce TC to 290K, and the second one is to increase TC to 305. So we need to do 2 simulations. In the first simulation, we save the data into the time and the concentration A, and also temperature to T1, CA1, and T1. In the second simulation, we change the name to T2, CA2, and also the temperature 2. Based on that, we could plot the profile of the temperature for different scenarios at the same figure. So now we do a simulation. So we change this one to CA1, and this one is T1, and this one is capital T1, right? Save it, and then click simulation, right? It's done. And then so in the second scenario, we increase the temperature TC to 305, so therefore we need to change here, and the final value here is 305. Right, change the TC. Now you see TC is going up, right? And then at the same time, we change the name here for the variable, this, and CA2, and T2, and capital T2, right? So you will see after the first simulation, and you should get data for first scenario, and then now save it, and then run simulation again. Then we get data for the second scenario. Okay, so the data already saved in T1 and T2 here, right? Okay, now let's plug the data together. So I want to show you here. You're going to type this into the command windows. Right. So T1, time 1, this for time 1, and this for temperature 1, and red represent the color, red color, and this and the dash represent the line type. So this is dash line, and this is solid line. Okay, this blue color, and this is line width. Right, if you want to know more about how to define the color of the line, and then the line type, and also the type of the marker, you could check this in detail. And here, make sure that you put hold on here, because we don't want to erase the profile for the first scenario, right? And so we're going to keep the profile for the first scenario, and then plot the second profile for the second scenario, and then we could see 2 profiles together here. So, right, and at the same time, we also want to put the legend here, And for example, this one, the first one is for temperature decrease to 290, and the second one is temperature increase. This temperature decrease. Here is temperature increase. Right. So this is what legend means. At the same time, you should put the label for this S label and Y label. Right. It's pretty straightforward, and you could copy my code into the command window here. Just copy and paste. Right, then run the simulation. See, this is the result. Beautiful, right? It's the same result as the one I show you in the handout. Okay, it's done.